The best way to explain rainbow tables is to compare this kind of attack to the brute force and dictionary attacks. When an attacker brute forces a password, he has to generate a hash for every attempt or for every possible password combination he has. Then he compares the resulting hash to the hash in the table he wants to crack. If he gets a match, then he knows a password. So to speed things up, what if this attacker saves his brute force work by creating a table for all the password and hashes he was generating? Next time, he only compares two hashes. So this will save the computation time to convert an alphanumeric password to a hash and then compare this hash to the hash in the table he wants to crack. This will significantly speed up the cracking process. However, the table would have to be huge to have every possible password. So as you see, a rainbow table is a file of pre-computed password hashes. Rainbow cracking is proven to be more effective and less time consuming than brute force and dictionary attacks. So it uses less computer processing time but more storage. So before we can begin to crack hashes using rainbow tables, we need to generate these rainbow tables. We can generate them using the tool RTgen. Here you can provide the hashing algorithm, whether it's MD5, MD4, SHA-256, etc. And then your character set. It can be alphanumeric, lower alpha, it can be numeric, etc. And these two arguments are the size of the password, the length of the password, minimum and maximum. Then we have these parameters here, which are related, to be honest, to advanced cryptographic stuff. We will not go deep into that now. I'll give you just general guideline on that. The table index is actually the reduction function we will have in this rainbow table generated. Meanwhile, the chain length is simply the length of the chain you want to generate, and the chain number, as you can see, that rainbow table is actually an array of rainbow chains. So here you specify the numbers of the chains you want to have in this rainbow table, and the part index is actually to store the large rainbow table in smaller chunks. So don't worry about these, just focus on the first two or first couple of arguments. So let's start by creating rainbow table here for the MD5 algorithm. I will use numeric as my character set, and the minimum length is 1 and the maximum length is 8. Then I will use these default values like 0, 1000, 1000 and 0. Now it generated this rainbow table. If you go to list, you will be able to see, actually not here, we need to go to RainbowCrack, and actually this is the directory here. So let's go to this directory and we will be able to see the rainbow table file generated here. This is the rainbow table file. Next, we need to sort this file. We will invoke the command RTsort and just provide the path just by using a dot. After we have generated the rainbow table and sorted it, now it's time to crack a hash using this method. So we will use the command rcrack. You can see here the syntax, which is very easy. Just write rcrack, then use dot to refer to the rainbow tables found in the current directory, then provide the h argument and provide a hash. For this purpose, we will go here to an online MD5 hash generator and just select any string like this one. Just copy the hash here, then paste it and hit enter. It's very fast, as you see, and the results are here. This hash corresponds to this password.